Friction and wear. Have you asked yourself how you stand firmly on the floor and why the phone is sliding slowly on an inclined surface and how the car stops? I'm sure that you know the answer is friction. Friction is a resistance to relative motion between two bodies in contact. It's not a material property, but a system property. Scientists believe that it occurs due to an electromagnetic attraction between the charged particles in two surfaces that are in touching. There are several types of friction, including static friction, which occurs when two objects are not moving relative to each other. For example, the chair on the ground. Also, we have the kinetic friction, which occurs when two objects move relative to each other and drop together. For example, when the person is sliding down slides. Also, we have the rolling friction, which occurs when two objects move relative to each other and one of them are going to roll on the other. Like for example, the car wheels on the ground. We have the sliding friction, which occurs when two objects are rubbed against each other. And we have the fluid friction, which occurs when a solid object moves through a liquid or gas. For example, the jet moving through the air. Friction plays an important role in manufacturing processes because of the relative motion and the forces that always present on the tools, the pliers, and the workpieces. The friction dissipates energy, thus generating heats. Also, this embeds free movements in the interfaces, thus significantly going to affecting the flow and the deformation of the materials in the process during the metalworking processes. However, the friction is not always undesirable. For example, without friction, it will be impossible to roll a metals, clamp a workpiece on the machines, or hold a drill bits on the chuck. There are a number of explanations for the phenomenon of friction. The commonly accepted theory of the friction is the adhesion theory, which is based on the observation of that two clean and dry surfaces, regardless of how smooth they are, contact each other at only fraction of their apparent contact area. In such situation, the normal contact load is going to be supported by a minute asperities that are going to be in contact with each other. Therefore, the normal stresses are going to be all these asperities are high, and this will cause the plastic deformation at the junctions. Their contact creates an adhesive bonds, asperities form of the micro welds. The cold pressure welding is based on this principle. Another theory of the friction is the abrasion theory, which is based on the notation that an asperities from the hard surfaces are penetrated and blows through the softer surfaces. The blowing may first cause the displacement of the material and or the produce of the small chips or fibers as in the cutting and the abrasive processing. Other explanations for the frictional behavior have been suggested, but for most of the application in manufacturing, the adhesion and the abrasion mechanisms are the most relevant. The sliding motion between the two bodies with an interface, as just described, is possible only if the tangential forces is going to be applied. This force is called the friction force, is required to shear the junction or blow through the solvent material. The ratio of the friction force over the normal force is called the coefficient of friction. The coefficient of friction can be found experimentally. Depending on the materials and the processes involved, the coefficient of friction in manufacturing can be varied. For example, in metal forming processes, the value of the coefficient of friction ranges between the value of 0.03 for the cold working to 0.7 for the hot working, and from 0.5 to as much as 2 for the machining processes. Almost all of the energy dissipated in overcoming the friction is going to be converted to a heat, which is going to be raises the surface temperature, and a small fraction of the energy will become as stored energy in the plastically deformed surfaces. Temperature is simply going to increase the friction and the sliding speed, and decreasing the thermal conductivity of the material, and decreasing the specific heat of the sliding material. An interface temperature may be high enough to soften and even melt the surfaces, and sometimes it's going to cause the microstructural changes in the materials involved. Because their strength is low compared to that of the metals, the plastics generally going to possess a low frictional characteristics. This property will make the plastic better than the metals for bearings, the gears, the seals, prosthetic joints, and the general friction reducing operations, provided that the loads are not going to be high. Because of these characteristics, the polymers sometimes are described as self-lubricating. The frictional behavior of the ceramic is similar to that of the metals. Hence, the adhesion and the blowing at the interface contribute to the friction force in the ceramic as well. Usually, the adhesion is going to be less important with the ceramic because of their high hardness, whereby the real area of the contact at the sliding interface is going to be small. The friction can be reduced through the selection of the materials that have low adhesion and through the use of the surface films and the coating. Lubricants such as the oil or the solid films such as the graphite interpose and adherent films between the tool, die, and the workpiece. This film will minimize the adhesion and the interaction of one of the surfaces with the other, and thus we are going to reducing the friction. The friction also can be reduced significantly by subjecting to the tool or the die workpiece interface to an infrasonic vibration, usually at the range of 20 kHz, to allow the lubricants to fill the gaps evenly. The wear has an important technological and economical significance because it's changed the shape of the tool and the dies, and consequently is going to affect the tool life, the tool and the die dimensions, and thus the quality of the parts produced. Usually the wear is a side effects of the fraction. The importance of the wear is evident in number of parts and components that continually have to be replaced or repaired. Examples of the wear in the manufacturing processes include the drills, bits that have to be grounded, the wound cutting tools that have to be indexed or changed, and the tools dies that have to be repaired or replaced, and a countless of the other situations. Although wear generally alters the part surface topography and may result in a severe surface damage, it can also have beneficial effects. The running-in periods for the various machines and engines use a wear in order to remove the peaks from the asperities. Thus, under controlled conditions, the wear may be regarded as a type of smoothing or depolishing processes. Note that writing with the ordinary pencil or chalk is a wear process, and the words written actually are formed from the wear particles. The wear can be classified into adhesive wear, abrasive wear, corrosive wear, fatigue wear, erosion, fretting corrosion, and the impact wear.